Hi, this is Brad Seacott with Terracom, and in this short video we're going to talk about the Luna OBR4600, and in particular we're going to talk about sensitivity and dynamic range. What's the difference? What does it mean? Probably the easiest way to get to where we're going to go is go to the Terracom web page and then click on Partners, and then click on Luna. All right, and then you can go to the different products. We're going to go to, oops, where are we? Products. And we'll go to the OBR4600. Okay, and all the information's there, specifications, documentation. The two things that we're going to worry about today are this sensitivity number and the dynamic range number. Okay, so let's talk a little bit about that. I'm going to go pull up a presentation that we did a while ago. So there's two numbers that we have to worry about, right? One is the dynamic range and one is the sensitivity. So here's a typical picture of a shot of some fiber with some connectors. There's an optical switch. There's a bad connector. Why is it bad? Because the return loss is so bad, right? You can see the return loss on the side here. Good splice. You can see a lossy splice here. Okay. Oh, what is that? Oh my gosh. So you can see a lossy splice there, and you can see another splitter and some Bragg gratings and so on. Okay. The important thing to notice is these numbers here. What we're looking at right here is the backscatter of the fiber as we go through. All right, and it's dropping and it's dropping and it's dropping. Okay, and so the question becomes, how close can we get to the noise floor of the unit before we run out of space to measure things like this loss here? Okay, so let me go ahead and pop over to a drawing. Okay, so I apologize for my bad drawing here, but to illustrate the point, so our sensitivity is minus 130, okay? Which means that the sensitivity of the instrument is down around here. Right? Typical backscatter for SMF58 is minus 118, I believe. All right, so that means, you know what, let's do that a different color. That means that standard fiber is going to be here. So we have a certain amount of range that we can play with before we hit the noise floor of the instrument. Okay, and I think that information is reflected in the insertion loss dynamic range. That's where this 18 dB comes from. This 18 dB is how far you can go down between the backscatter of standard fiber and the noise floor of the instrument. Okay, but that's not dynamic range. What dynamic range is? Dynamic range is the distance that we can go from the uppermost peak down to the lower part of what the instrument can read. So if I have a very big reflection here, say this reflection is like minus 30 or something, right? Okay, so what that means is at minus 30, we have 80 dB of dynamic range, 8, 9, 10, 11. So that means that we can go down to minus 110. Okay, dB. And no lower, because the detectors get swamped out. Okay, so that's what we call dynamic range. So if you want to get down to these low levels, you have to keep the reflections low. Okay, so I'm going to draw another one in here. Let's draw a blue one. All right, now if I can keep the reflections low, like down around here, then I have a tremendous amount of dynamic. I have all this dynamic range that allows me to get closer to the noise floor of the instrument. Okay, so think of the 80 dB dynamic range as a window that you can move up and down. All right, and what moves that window up and down is the strength of the highest reflection that you have. Okay, so when we're talking about, so what does this mean? Well, what it means is, let's go ahead and erase a lot of this stuff in here. What it means is that if I'm above the noise floor of the instrument, then I can measure the insertion loss of what I'm interested in. Okay, so say I have a fiber here at about -115, right? And say I've got a fusion splice, and the fusion splice has terrible loss, right? So I can measure this loss in here, right? And this is the insertion loss of the fusion splice. Say I have another splice in here, and that's a mechanical splice, right? And I have some loss due to the mechanical splice. I can measure that loss as well, right? Where it becomes difficult is if I start getting close to the noise floor of the instrument, I'll still see peaks. So say I have a really bad splice here, right? So we'll put a real bad one here, really lossy. And say, for the sake of argument, that the loss brings us down below the sensitivity of the instrument. All right, I'm going to draw this sensitivity line over here. Okay, so what this means is that we won't be able to measure this insertion loss accurately. Okay, but what we can do is we can still measure the peak, right? We can still measure the distance of that peak. We still have plenty of sensitivity. And actually, you can get down to points where you're still measuring peaks even if the backscatter or whatever is below the sensitivity of the instrument, right? You'll still be able to measure peaks. Okay, so again, keep in mind that you have an 80 dB window from peak to valley that you can move up and down based on what your peak reflection is. All right, and you have a -130 dB floor, and really, I mean that's the absolute bottom. So you're probably going to want to be in the -120, -125. Okay, so I hope that kind of clears up the difference between dynamic range and sensitivity. If there's any questions, go ahead and give us a call. You can reach us through the website. If I can ever find the website again, there it is. You can go to resources. Well, you can get more videos at resources. You can go to regional line cards, and you can reach us through there. We have our phone numbers for the different regions, and we have our email addresses as well. Okay, I hope this is helpful.